Hey there, welcome back everybody, and in this particular video we are going to talk about database backed authentication with Spring Security. Yes, so we are going to cover how you can actually secure your application using a database. So using a database meaning you can store all your user credentials, information, their roles and everything in a database, right? So there is a persistent storage in the hindsight that's saving your user information. Okay, so far what we have done is we have in-memory authentication, and our users' details are being stored in memory. Okay, but all modern day application will have databases, and databases are pretty common these days, right? So yeah, it's important that we see the database part of Spring Security as well, and that's what we are going to cover from scratch, step by step. Okay, I'm also going to explain you things like hashing and password encoding. Now, when it comes to database authentication, it's important that you don't store your passwords, like your user passwords, in a plain text format, right? Otherwise, anyone can see it, or if your database gets hacked, hackers can see it, or developers can see it. So it's best to store in such a way that they are encrypted and in non-readable format, right? So that's where we are going to make use of hashing and password encoding. We are going to make use of inbuilt password encoders, and we are going to see how they can secure your application even more. Okay, we are going to understand the concepts of hashing and all as well. So it's going to be a very useful video. If you're watching my video for the first time, or if you're new to this channel, I would highly encourage you to check out the description for the link to the earlier videos. So the description has a link to the entire playlist. Okay, so you can get access to the earlier videos and the video afterwards. Okay, so that's going to help you get some context as to what we are doing. So just to tell you, we are covering Spring Security from scratch, from basics to the advanced level. Okay, so be sure to take the benefit of the playlist. Also, if you haven't liked this video yet, be sure to hit the like button, and also you should subscribe to my channel and turn on the bell notification icon, because that is going to motivate me to bring more such amazing free content for you all. So number of likes, subscribes, comments, all these metrics impact my ability to bring such content on this platform. Okay, so be sure to support me and get benefit of the content that I'm posting here. Also, I would love to know more about you, like who you are, where you're joining from, what do you do currently, what sort of videos you would want to see on this channel. So be sure to leave all this information in the comment below. Okay, I'll be reading your comments personally. Sure. So yeah, that's about the video. There is a lot of information packed in there. Do watch it till the very end. Let's jump right in. So far, what is happening is we are making use of in-memory user details manager to create users in memory, which means that these users are not getting created in the database. We already have a data source or a database configured with our application. And right now we are making use of H2 database, right? So it's time that we start moving these users instead of in memory to the data source or the database that we have configured. So tomorrow it might be like you might have, instead of H2, you might have PostgreSQL or MySQL or any other database configured. And what would happen is, with the changes that we are going to do, you would be able to create users over there. All right. So here in the security config, what we need to do is we need to make use of something called as JDBC user details manager. Okay. So here I'll just type in, okay, JDBC, and you can say user details manager. You can see like this is also a user manager. Okay. It's a, so if you go over here, you can see over here, it's a user detail manager. It's an implementation of the same. Okay. And if you go over here in memory detail manager, it is also a implementation of this. Okay. User details manager, but the purpose is different. This is used to create users in memory. This is used to create users in a database. Okay. So what we are going to do is we are going to make use of JDBC user details manager, and I'm going to create an object over here. So I'm going to say user details manager is equal to new JDBC user details manager. Okay. Now what happens is this JDBC user details manager
needs a data source. So if you go to the class here, you will see, so this is a default constructor with no parameters, but it also accepts parameters. This is another constructor where you can pass in a data source, and data source is nothing but actually it's source of data. Okay, so wherever you are storing the data in your application, and right now in our application we have a data source configured. So here, if you see here, we have these properties, and these properties indicate that there is a data source configured called H2, okay, which is H2 database. So what I would do is I would make use of data source over here. Okay, so I'll say data source, and I'll get this auto wired. Where do I get this bean from? So actually, if I specify something like this, what I'm saying is that inject the dependency called data source into this particular object. Okay, and how does this happen? So what would happen is Spring Boot will automatically make use of auto configuration to set up a data source bean for us. And you will ask, hey, how Spring Boot would automatically do this? So it has all the configurations of your project. Okay, it knows that in pom.xml you are making use of H2 database, JPA, okay, and in application.properties you are specifying these two properties. So based on this configuration that you have provided to Spring Boot, it will automatically have a data source bean available for you, and it will automatically set up this bean, and it will auto wire over here because here you are asking for it. Okay, so we'll have this. We don't need to define this because this is automatically taken care by whom? Like I said, Spring Boot. Okay, so I have this bean created here, and what I would do is I would come over here to user details manager, and I would pass in this object. Okay, now this is done. All right, and here, instead of sending this to in-memory user details manager, what I would do is here I would say user details manager dot create user. You can see this create user method here, and I can say over here user 1. I'll duplicate this. I'll say create user as admin as well. Okay, this is done, and here I can say return user details manager, something like this. So this is done. Okay, and this is taken care of. Okay, so what we have done is we have just replaced the implementation of in-memory user details manager with the help of JDBC user details manager. That is it. And this will make sure that our data is being stored in the database. Okay, there are a few things still pending, but let me run this and show this to you. Okay, so it will throw an exception or an error. I should warn you in advance, but we'll see that error and we'll learn something. Okay, so you get an error. So I'm purposely generating this error. You can see this error now. It's telling you that table users is not found. Okay, if you scroll up, okay, is it the same error here? Okay, user details, you can see users not found. So it's trying to run this and it's getting an error. Okay, users not found here. It's all about the schema being non-existent over here. Okay, so you can see if you take a look at, if you read errors, this query is again failing. So we got same error twice because we are trying to create two users. Okay, so let me tell you, in order to save details of a user into the database, you first need a schema. Now, what is a schema? Schema is nothing but a structure of the database. Okay, like you need some tables already created inside which you are going to store the user details, right? And here what we are doing is we are making use of user details that is inbuilt, right? So we can make use of some default schema that exists with Spring Boot. So what we are going to do is we are going to head over to GitHub. Okay, so for that we are going to head over to browser, and I'm going to search for Spring Security GitHub. Okay, so you'll find the official source code of Spring Security on GitHub over here under Spring Projects. Okay, and here you can search for users.ttl. Okay, if you search for this, you should see this location: core src main resources org Spring Framework Security. So under security, it's under core user details, JDBC and users DLL. Okay, so if you come over here and if you go to this file, user details, okay, you'll find org.spring-framework security. Okay, so you'll find over here org.spring-framework security, then core user details. Okay, so you can see core user details. Okay, so this is a path. Okay, and within core user details, it will go further calling JDBC and users TDL. So you will go to this particular file. Let's go to this file, and you can see this file with some schema over here, like the schema definition. Okay, so this is the schema definition that we need in order to like have the tables and everything created where our users can be stored. Okay, and what we can do is I'll just copy this, like just copy this thing over here, just come back to your project and just go over here. So what we need to do is we need to make sure that H2 picks up this particular schema, and when the application starts, it is created automatically. Okay, so what I'm going to do is I'm going to create a new file over here, which is going to be schema.sql file under resources, and here I'm going to paste that schema that I copied. Okay, so this is an SQL file. Okay, and this is saved. Okay, so yeah, this is done. And yeah, what would happen is I'll tell you. So since we are making use of H2, which is an in-memory database, the data gets cleared, and hence we need to get the table created when the application starts. So if you are using some other type of database like MySQL and PostgreSQL, which are non-memory database, then in that case, the schema will persist. Okay, so in that case, what you can do is you can copy these SQL commands and you can run it in the respective tables or respective database over there. But for this, what we need to do is for every application start, we need to make sure that this schema is loaded into the database. Okay, so to load an SQL file on an application start in Spring Boot application, especially for setting up security or initializing any sort of database table, you can make use of Spring Boot's automatic schema initialization feature. And this feature automatically runs SQL script during the startup, which is particularly handy for creating schemas like this. If you want to insert any default data, you can do that, or you can configure any sort of tables or anything for that. And the process is you just need to create a schema.sql file under resources folder over here, and it will automatically be picked up by Spring Boot. Okay, and since we are making use of everything default, right, we don't have our own custom user details or our own user structure. We can make use of default schema which exists with Spring Security. And where did we get this schema from? We got this schema from the official source code of Spring Security, as I've shown you. Okay, and what we will do is we'll run this code again. Let us run this code and let us see what happens. So earlier we were getting an error. Now we are not getting an error, as you can see. Okay, so the error is gone and it indicates that schema has been created. And to confirm, what I would do is I would just head over to H2 database. I'll connect, and you can see two tables automatically appear over here. One is users and one is authorities. So if you take a look at this schema definition or the queries over here, you're creating two tables. Okay, now let me take you to the tables. Okay, if I say select star from users, you can see your users are also created. Isn't this amazing? Okay, your users are also created. You can clear this. Authorities, you have some authority as well. So admin has the role of admin, user has the role of user. Okay, and this is something you like just got created with few changes in the code. Okay, so you just added schema.sql and you updated this thing to work with user details manager. Okay, and now if you test your application, it is going to work with these credentials. Okay, so if you come over here, okay, and here if I say user1 and password1 here in the basic auth, okay, and if I say send over here, okay, we got an error. Okay, so I'm trying to access the admin API. Okay, so I'm saying /admin. So let me head over to the controller. Okay, so if you go to admin, I can say /user over here. Okay, so if I say /user here, if I say send, you can see hello user. Or if I go to hello, this should work. Okay. This should work. You can see perfectly working and it's amazing. Okay. So this is how you can move everything onto the database without making use of in-memory stuff. Okay. Still we are making use of H2 database, which is right now in memory. But if you have any sort of database like a Amazon RDS, for example, remote database, if you have a project that is making use of SQL, if you have a project that is making use of MySQL, PostgreSQL, any sort of other database, you can do things this way. And in that case, if it's not an in-memory database, you don't need to add schema.sql like this. Okay, we have added this because, like I explained, we are making use of in-memory database because the data is being cleared on every application restart. So you need to have schema that is loaded every time the application starts. And this is the simplest way of setting things up. Okay. So yeah, this is working absolutely fine. Still, you will be able to see the password in the database. And this is not a good practice right now. We are not making use of any encryption mechanism right now. But yeah, we are getting there. Okay. So we are taking one step at a time. But yeah, things are working. And from in-memory, we have graduated. I should say graduated. Okay. Because we have come so far. So from in-memory, we have graduated to the database backed authentication. And that's amazing. Pat yourself on the back. So that's about the database authentication. And I hope this was useful. So now it's time that we talk about hashing and understand what it is. So what is hashing? Now, hashing is a process wherein if you have a message that needs to be transmitted, okay, or sent over the network, then in that case, you can hash the message, which means that you can take it through a process where the message looks something different than the original message. So I should say not something, but it looks a lot different than the original message. Okay. So if you come over here, let's say as an example, I have this message or a string I wish to send to the server over a network. And the string is programming. Okay. Now I can make use of hashing and I can convert it into something called as this or something like this. You can see the string. This string looks very different than that of programming. Okay. And this process of converting programming like a normal string to something that looks like encrypted message, it's called hashing. And this is what hashing is in simple terms. Okay. So hashing, it's a one-way process. Okay. And you can't turn it back into like the original string that you have. Okay. And once the other side receives this string, it will decrypt it and convert it into original message. Okay. So this is what hashing is. And how this hashing works is it involves making use of algorithms. So there are different algorithms that exist, and these algorithms are used to work on the message or the string, whatever data you're willing to transmit, and you get the hashed value. Okay. Now there is one such algorithm called Bcrypt. Okay. And it has a feature called salting, which is something that we'll talk about. But Bcrypt is an algorithm that is often used and it is considered as secure algorithm, wherein using Bcrypt, you can take a message, you can pass it through the algorithm and you'll get a encrypted message. Okay. And Bcrypt is one of the most popular algorithm that is used widely. Okay. So if you read about hashing online, it's unlikely you won't come across a Bcrypt. Okay. And it has a process called salting. Okay. So let me tell you what is salting. So salting helps increase security. How? So what happens is normally you would hash this particular value, right? So you have programming and you would hash it into something using the algorithm called Bcrypt. Okay. Now, what salting would do is it would add an additional layer of security, which means like you have this string. Okay. So you would add a random string over here, randomly generated string or any data, which is known as salt. Okay. And then together these two will be used to convert into hashed value. Okay. So password, or so this can be a password as well, or any sort of data. Okay, normally passwords are encrypted. Okay, that is where encryption is used, hashing is used. Okay, all of that. So any sensitive data, but if you're working on any sort of application, like for example banking application, where like a lot of stuff is hashed, you may hash a phone number, okay, of a user if you are working on a security grade application, something like that. Okay, so programming here, let's say it's a password, you would add some salt to it, and then these two would be hashed together using Bcrypt. Okay, and this process is known as salting, and this thing makes this algorithm even more secure. Okay, because for every hashing that happens, the salt changes, so you cannot predict what the salt is. The message can be same, but if you add different salt, the output would be different. So here you have programming plus this salt, which is XWZ78. Okay, if you add some other salt over here like this, okay, then you will get a different value. So you can see over here this value is different. Okay, that is how the entire process works of salting, and this is how it processes this is how it makes sending data easy and in a secure way. So if you are storing this, let's say, or if you're transmitting this data over a network, you can transmit the hash value. Or if you're storing this password, let's say programming is a password, if you store this as a raw text, it would be readable. But if you hash it and encrypt it, something like this, wherein you add salt and then you convert it into hashed value, then this is not readable, right? Nobody can tell what your password is, right? Unless and until it's reverse engineered. So this is much more secure way of storing passwords. And this is even used to send some data which you don't want others to understand over a network. Okay, so that's hashing, and that's about Bcrypt and the process of salting. So I hope this was useful. Now it's time that we implement encoding or encrypting into our application. So right now I have this application up and running. I have the users being created over here. So these are the users that are being created into the database using JDBC User Details Manager. Now, if you come over to the H2 database, okay, or H2 console, I should say, and if you log into the H2 console and then if you query the users table here, you will see users table having this data. So the passwords are stored in this way. Now, this is not actually a good way to store passwords because these passwords are readable and anyone who has access to the database can access this information, which is not good. So passwords need to be encrypted, and there has to be one more layer of security that we need to add to as a best practice essentially. And it's not good to have passwords being stored in plain text format. Okay. So what we are going to do is we are going to encode our passwords, and we are going to make use of password encoder. Okay. So here, what we are going to do is we are going to say public, and I'm going to make use of password encoder over here. Okay. So if you hover on this, this is an interface. If you go over here, and this is a service interface for encoding password. Okay. And you can see the most preferred implementation is Bcrypt password encoder. Okay. And yeah, so that is what it is. And if you see Control B over here, okay, so I'm not getting, okay, here you can see password encoder. Okay. Bcrypt password encoder. So if you press Control B, and here this is a class which is making use of password encoder, and you can see over here this is an implementation of password encoder that uses Bcrypt strong hashing function. Okay, and yeah, so this is what we are going to use over here. So I'm going to say password encoder here, and we can name the method whatever we need. Okay, so I can say password encoder over here. Okay, because that's what people normally name it, and I'm returning the instance of this interface of, so the instance has to be of type password encoder. Okay, and I'm going to say return new Bcrypt encoder, right? Bcrypt password encoder. So I'm just getting it like this, and what I also need to do is I need to mark this as a bean. Okay, like so. Okay, so this is done, and we have an instance of password encoder. Okay, now in future, if you need to change the encoding algorithm, you have to just come to this bean and give that particular instance. If you have your own algorithm, so this is inbuilt, right? This is inbuilt, and within the security framework, okay, Spring Security over here, you can see it's coming in from this package, okay. So this is pre-built, but if you have your own algorithm or anything, you can instantiate it over here, all right. And what we are going to do is we are going to make use of this when saving password, okay. So understand this. Here what we did is early on, we made use of this prefix over here. This prefix stands for Noop, okay. And what is Noop? So the Noop prefix that we are using in our password is a way to tell Spring Security password encoder that no encoding has been done, okay. And the password should be used as it is, okay. This is useful if you're building a demo application where you don't want to encode stuff, okay. But normally you would get rid of this, okay. And what we would do is we would say over here, within this, we would say password encoder, and you'll say dot encode. And within this, you'll pass in the password that you wish to encode, something like this, okay. This is done. And I would copy this, okay, and I would come over here and I would paste it over here. I would remove Noop from here, and I would add a closing bracket over here. So this is done, all right. And let us see how this works, okay. So we'll rerun our application and we'll check how the values are being stored in the database. So we did not get any error, you can see. Now if you come over here, this is how we were seeing the password currently. And if I say refresh and if I connect again and if I go to users table, you can see this is the password now, okay. So yeah, this is not readable now, and anyone who is having access to the database cannot read what the password is, okay. So this is really helpful over here, okay. And you can imagine as to how, so you must have seen a lot of applications doing this, right? And in Spring or in Spring Boot, this is how you do it, okay. So you hardly like made use of inbuilt classes that you had, inbuilt implementations, and you just made use of a method over here to get this encoding done, okay. And this is automatically making use of salt and everything, okay. So you don't need to worry about that, all right. So yeah, this is about password encoding. I hope this was useful.